These are the examples for Algebra 2A Credit 1, Lesson 2.1. All right, so the first graph will be an example for problems 1, 2, and 3. We're going to be asked to find the vertex, write the absolute value function, and then to state the domain and range. All right, so the vertex of our absolute value graph, the vertex is this bottom point where the two sides of the absolute value meet right here. And so the vertex here would be at 4 to the right and then 2 up. So remember, in any ordered pair, the first number is our x value. So that's a positive 4. And then we're going to go 2 up. So 1, 2. That's a positive 2. So our vertex is at 4 and 2. Be careful that you don't do that backwards, because if you do 2 and 4, that would be 2 to the right and then 4 up, and you'd be somewhere up here, which is, of course, not what you want. Now we're going to use the general form of an absolute value function to write the function. And so we have our vertex. Our vertex, of course, any ordered pair is x and y, but as far as connecting it to the function that we're going to write, we can think of this as h and k. In other words, the x-coordinate will be your h, the y-coordinate will be your k. So to write our function f of x, let's go ahead and copy this down here. H is 4, but remember the general form has that minus h. So it's x minus a positive 4 and then plus k, which is 2. And so that is our function. Now, you might wonder, well, if the h was negative, does this become positive? And yes, that would be the case. But as it is, h was positive, so x minus a positive 4. So we have our vertex, we have our function, and now we're going to state the domain and range. And we'll just use D for domain and R for range to represent those. So the domain, whenever we're thinking of domain, we're thinking of the x values. And so for any absolute value function, the graph goes out forever to the left into negative infinity and forever to the right to positive infinity. So the domain, which they're going to actually write, well, we're just going to write it out in words, is always going to be all real numbers for any absolute value graph. So that's almost like a freebie. And again, that's because the graph goes forever to the left. And yes, it's going up, but it's also going to the left. And then similarly to the right, it's going out forever to the right. So the domain will always be all real numbers, because for any value of x, we can go up or down and find a point on the graph. The range, so for the range, it does go up forever, but the graph doesn't go down forever. It does have a bottom point here at 2. And so the values for this absolute value function are from 2 and above. And the way we represent that is y is greater than or equal to, because it does include 2, y is greater than or equal to the number 2. So again, domain, all real numbers, range, y is greater than or equal to 2. And so we're going to take a look at another example over here for problems 4 through 6. So on this one, our vertex, to get to our vertex point, now this time the absolute value function is facing downward, but our vertex is still that corner where the two sides of the absolute value function meet. And so the ordered pair that defines that point would be 4 to the left and 2 down. So that would be negative 4, and then 2 down, negative 2. So our vertex is at negative 4, negative 2. And again, make sure you don't switch those, because if you did negative 2, negative 4, that would be 2 to the left and 4 down, which would not be where the vertex is. Now, using the general form, let's go ahead and copy this down here. So now, remember, our vertex is our h and our k. The x-coordinate is your h, the y-coordinate is your k. So we have x minus a negative 4, or I should say the absolute value of x minus a negative 4. And then k is a negative 2, so minus 2. Now, we can simplify this. Remember, minus a negative, that just is addition. So we have the absolute value of x plus 4 minus 2. And so that is our function for this graph here. Now, lastly, the domain and the range. Remember, we said the domain for any absolute value function is going to be the same. It goes out forever into the negative to the left, and then forever to the right into the positive. So our domain is going to be all real numbers for this and for any absolute value function. For the range, it does go down forever this time, but it doesn't go up forever. There is a maximum point or a top of that absolute value function, if you will, here at -2. So this function has values for -2 and not above like we had over here, but -2 and below. And so our range is going to be everything not greater than -2, but less than or equal to -2, because it does include that point here at -2. So again, our domain, all real numbers. In our range, everything that's less than or equal to -2, because remember, your ranges are those y values. And so -2 is the highest, the top point, if you will, of our graph, and then everything below. So -2 and below. All right, that's the examples for lesson 2.1. Remember to pause, just making sure we got everything. Well, we didn't get quite everything in there. There we go. Make sure pause, rewind, rewatch as needed. Just want to give you a chance to see the example there. And good luck with the work, and we'll see you in the next video. Take care, and God bless.